In this tutorial, we will describe the chemical properties of transition elements. The transition elements are much less reactive than the metals in group 1. So if you want to compare the reactivity of the transition elements and the alkali metals, we will find that transition elements are much less reactive. And this conclusion is based on the reactions of transition elements with oxygen, chlorine, or water, for example. Because the transition elements won't react with oxygen, chlorine, or water as alkali metals do. Let's take an example. Here we have a copper foil which has to be heated strongly before it reacts with oxygen gas in the air. And the product will be a black coating of copper 2 oxide, which will form slowly on the surface. So alkali metals react really fast with oxygen, whereas transition metals such as copper, Cu, needs to be heated very strongly before it can react with oxygen gas to produce the metal oxide copper 2 oxide. This is the reaction. 2 copper, which is solid, will react with oxygen gas O2 gas to produce 2 CuO, solid, copper 2 oxide. So transition elements will react with oxygen to form a metal oxide. However, the reaction is slow and it needs to be heated strongly. Another example is the reaction between iron and chlorine gas. Iron reacts much slower with the chlorine gas than sodium does. And actually, for a reaction to take place between iron and the chlorine gas has to be passed over iron and heated very strongly inside a horizontal Pyrex tube. The product will be red iron 3 chloride. So iron will react with the chlorine gas, and for this reaction to take place, chlorine must be heated very strongly inside a horizontal Pyrex tube. The product will be red iron 3 chloride. So 2Fe, which is solid, will react with the 3Cl2 gas, chlorine gas, to produce 2FeCl3, solid, iron 3 chloride. Moreover, copper will not react with water, so there's no reaction between copper and water, unlike the vigorous reactions of the alkali metals with water. In conclusion, transition elements are much less reactive than the alkali metals. Actually, many of the transition elements form colored compounds, so compounds containing transition elements have different colors. Let's take some examples. We have copper 2 sulfate, which has a blue color due to the presence of Cu2 plus ions. We have, for example, nickel sulfate, which has a green color due to the presence of Ni2 plus ions. This is potassium chromate, which has a yellow color, and this is potassium dichromate, which has an orange color. So both of them have chromium ions, however, they have different colors. You may have noticed that the name of a compound containing a transition element usually includes a Roman number. For example, we have seen copper 2 sulfate. So notice the Roman number 2 after copper, which is the transition element. Or another example is iron 3 oxide. Notice also the 3 over here after the name of the transition element, which is iron. Why do we need to use these Roman numbers? This is because the transition elements can form more than one ion. So to differentiate between these ions, we will use these Roman numbers. For example, iron may exist as Fe2 plus or Fe3 plus ions. These two ions have different colors. For example, iron 2 ions Fe2 plus give compounds a green color, whereas iron 3 ions Fe3 plus give compounds a reddish brown color. Another example is copper. Copper can form Cu plus ions and Cu2 plus ions. So this is why it's really important to use Roman numbers to indicate the oxidation state of the ion. Transition elements and their compounds are very important in the chemical industry because they are used as catalysts. So they are used to speed up reactions. For example, nickel Ni is used as a catalyst in the manufacture of margarine. Iron is used as a catalyst in the Haber process to make ammonia. So to make ammonia from nitrogen and hydrogen, iron is used as a catalyst.